A customer sent in their controller board from a Frigidair unit, which is apparently not working properly. When we received it, as you can tell, there was a lot of damage right here. There's a component that burnt up, and we have a little bit of browning on the bake elements. Now, for those of you who don't know me, my name is Nick. I started Nick's Electronics Repair over a decade ago, and since then we've fixed over 26,000 devices. In this video, I'm going to show you exactly how we diagnose and fix this controller board. So my first step is I don't want to live test this because it could cause more damage, but we are going to take it apart, and we're going to start by removing these clips here and here. Then we're going to go ahead and pinch them together, and we're going to lift the tan color controller board up and away. Now this one looks to be in good condition, so we'll put it to the side. We're then going to flip it over and see what we can find. The backside actually looks quite immaculate. If we zoom in, I am noticing right over here we have a little bit of browning, a little darkening, and it looks to be on the backside of where that component was that exploded. If we look at our baking element, that's quite browned. We can see it looks like the solder looks a little strange. We're gonna look at that a little closer under the microscope. But that looks a little odd. Now I did do a little bit of cleaning and it's almost perfect, but there is a spot right where the component was that I couldn't get any better than this. So this is all cleaned up. It was very dark before. And the component that used to be there was a resistor. And for those of you who are wondering, the resistance value was 220 ohms. So I do have a replacement resistor we're gonna go ahead and install. For the removal, I'm holding onto the pin on the front side, and I'm going to try and desolder it at the same time and pull it through. All right, and here we are. And we're going to do the same thing for the second pin. Let's see, I probably have to add some fresh solder first. Let me try without it. Okay, there we go. Sorry, that was a little off screen. Now we can go ahead and remove the extra solder. And I'm trying to be careful because the pads are a little fragile. We're gonna do a little bit more cleanup. Again, being very gentle. All right, next we'll go ahead and feed our replacement resistor. Now we can lock it in. And while everything looks okay, I just want to be sure. So with my multimeter in continuity mode, when I have a short, we get a beep. I want to make sure we have good continuity. And we do. And all the way to here. So we do have good continuity all the way to here. However, I am also now noticing that we have a very cracked solder joint right there. The resistor did burn up, and we need to make sure we understand why and how we're going to make sure to prevent that in the future. So it could very well be just because of this cracked joint right here. We're definitely going to want to touch that up, along with all of the other pins on this connector. All right, so let's go ahead and do that. We're going to add some flux. And next we can go ahead and touch up these pins, make sure we get good flow, and we're going to add a little extra solder. This one looks to be a no connect, we'll solder it anyways. We'll go ahead and clean up the flux in a moment. Let's take a look at some of our other joints. This first one here that we traced out to the connector, if we take another look on the other side, we have this joint here which looks fine, and the other side of the resistor goes directly to this joint, which is the large relay over here. And does that look cracked? A little bit. I wouldn't say it's fully cracked. I do see what looks like to be the beginning of a crack. There's a little bit of a ring forming, but I don't think that that's fully cracked to the point where I can say that caused arcing and extra power draw that shouldn't have happened. At least not like the other side where the pin connects that we just reflowed. So we'll still go ahead and reflow it because we don't want to have that crack get any worse and cause problems in the future. And we'll probably also want to reflow all of the other joints for that relay. So we have this one, this one. This is where the wires connect. We'll reflow those. And then the next one we wanted to look at was right here, the bake element connection. Now this one, P9, it looks like it is browned. It has some heat stress. And indeed, that joint does look a little odd. So same thing. I don't see a crack, but we're still gonna wanna reflow it. So we'll add some flux, and then we'll add some solder. But one thing I think we need to tell the customer is when they get this circuit board back, they'll want to inspect their wiring on their end, because I fear the wire connecting to this connector most likely was not making proper contact, could have arced, have improper connection, and it might be damaged at this point. So when we send this back, we will inform them to double check the other connections and wires on their oven, because those could also be damaged at this time, which means if they just put the controller board back in, they could have repeat issues in the near future, and obviously we don't want that. All right, the rest looks okay for now. And before we do any more repairs, I want to do a little bit more testing. All right, so we're switching back to our other camera, and the reason for it is we want to do a little bit of testing on these two white relays over here. For these relays, we have 6 pins. We have 2 over here, 2 over here, and 2 over here. Now, the 2 pins on this pad are not normally connected to the 2 pins over here. When there is power applied between this pin and this pin, these two all of a sudden should connect. And this will allow power to go from the LX connector over here to the baking elements. So this is our LX connector, which has power coming in, and then is transferred to the baking elements or to our broil element over here. So again, we're in continuity mode. We have a beep when we have a short. I'm going to put 1 pin on the pads with the LX connector and 1 on the broil. And we have no short. And then for the bake, we do have a short. So what that tells me is that this relay over here to the left that controls the baking element is stuck in the on position. That is not good, and that could actually be the full reason why this controller board started failing. So what that tells us is the relay was stuck in the on position, meaning the heating element for the bake function was constantly on even though it was turned off in the settings. That can be a little dangerous. Now let's go ahead and test them. And the way to test them is we're going to be using this DC power supply. We're going to inject voltage between this pin and this pin. This one is for the broil. So again, no shorts. I'm going to go ahead and keep pressure here. We'll turn on our DC power supply. And all of a sudden, we have a short. We have a beep from the multimeter. So that indicates that the relay activated. Let's turn off the power supply. The relay clicked off. No more short. That's how it's supposed to react. Okay, let's move both of our leads over to the what seems to be broken relay. So we're not supposed to have a short, but we do. Let's go ahead and turn on the power supply. We still have a short. Let's turn it off. And of course, we still have a short. So no matter what, this relay is stuck in the on position, constantly feeding power to our baking element, even if the baking feature is turned off. Now at this moment, I don't actually want to replace just the baking element relay. I'm gonna want to replace both. If we send it back out with just the baking element relay repaired, the broil function might fail in the near future, so we definitely wanna make sure both of them are replaced together. We're gonna go ahead and desolder the relays, and we're gonna use our desolder pump. But first we're going to add a little bit of solder to each joint. And now I'm actually going to try and cheat. We've desoldered the 4 joints over here, but let me see if I can cheat and just get all of these flowing at the same time and just remove the relay without actually fully desoldering. Hey, there we go. We got our first relay. Now, is that actually any faster or better? I don't know. We're just changing it up a little bit on the channel. Okay, and there's our second one. We'll use a little bit of desolder wick to remove that excess solder. And now we'll go ahead and replace those 2 relays. And I am noticing that there's actually just a little bit more solder we have to desolder. So I am going to be replacing them with slightly different relays, which are rated for about the same, actually just a little bit higher AC voltage rating. So technically you could consider it an upgrade. And I'm going to start by soldering down the center pins to lock in the relays so I can let go of them on the back side. Now we'll solder the bottom. And finally the top pins. And now we're going to touch up those middle pins again. Now, just as a precaution, I am going to also add a little bit of solder to some of our other contact pins, just to make sure everything is soldered in correctly, that there's no crack joints that I'm not noticing. Okay, and then the last thing we're going to look at is these 4 relays here. Now, I do believe they are all functional. There's no problems with them. And at this moment, we are also not identifying any crack joints. However, I have in the past seen that they can have crack joints. So preemptively, we're going to go ahead and reflow them. So again, we'll start with adding some flux to each joint. And this is all just preemptive repairs to ensure that we don't have any cracked solder joints in the near future. Now that's going to complete our repairs. Before we do a full live test, I want to recheck the new relays I've installed with our DC power supply to make sure that we're getting proper continuity. Okay, so prior to our repairs, we were getting a beep when I made contact between this pad and this pad, and we are no longer getting a beep. And I'm getting a really hard time I'm having a really hard time attaching this clip. Let's see if we can get it. Okay, and now when I turn on the DC power supply, we do have a short, which is good. Let's turn it off. Let's make sure it turns off. And it does. So that confirms that the replacement relay is working as it should. Let's make sure the other one over here also is working as it should. Again, I'm having a little bit of a hard time attaching the alligator clips. Instead, we're going to make contact here and here. We have no beep. which is good. We'll turn on the power supply and make contact. We heard the relay click, we have a beep, I let go, the relay unclicks and no more beep. So that confirms both of our relays are good and working. Now we can go ahead and put the controller board back together and live test in the oven. I have the controller board in the oven, and right now we're using a separate set of buttons because I don't have the originals. The customer did not send those. So we're gonna go ahead and trigger our bake function, and we're gonna wait a little bit and make sure that it works. Okay, and it does look like now it is at 101. We are now at 103, 105, so our temperature is rising. So now we're at 106, and there is actually something else I want to show you on the back of the oven. So we're actually going to cancel this off. Now what I want you to see is that we have our black power lead right here. Goes in through the LX connector. Then that LX connector connected directly to this relay, which was the one that was stuck on, which activated the yellow wire. Now the yellow wire goes directly down to our bake element and comes back up via the orange connector. If we follow that orange wire connection on the backside, it actually pops up right here on this resistor. So the reason the resistor blew is because this relay was stuck in that on position and burnt out the resistor. Okay, so this does complete our repairs for this oven controller board. If you're interested in sending in your controller board for us to fix, we do offer flat rate services which come with a 1-year warranty. Those will be available on our website, and that'll be linked in the description down below. Otherwise, if you found the video helpful or useful, make sure to leave us a like, subscribe for more content, and thank you for watching.